All right, so I wanted to do a video explaining caustics, specifically caustics with light probes and caustics inside of Lightwave, how to get it to work through the GI system. Um, so first of all, let me just kind of explain what the problems are with caustics and any GI system. And all of them have these same issues. So this is the light probe we're using, the exterior day outside cabin. Um, and you'll notice that it's CSP. What that means, as I explained in my other video, was that there's been a sun painted in with the correct intensity. Um, so what I do is when I take these light probes, I capture a ton of dynamic range. But one thing that's extremely difficult to capture is the sun. So I use other software to essentially paint it in with the correct temperature and the correct intensity. And it works great. So, but the tricky part is when you're doing caustics, essentially it means you've got this really intense spot out there that will make it hard for renderers to do. So let me show you what's happening. So we have limit in our rendering engine right now. This is Lightwave, and it's got important sampling, and that's for essentially the diffused GI. So that works great. When we turn that off, like I showed on my last video, you can see that it's going to take a while to clean that up. And what that means, like I explained before, is because all these rays go out in all these different directions. Some of them hit the sun, which is very intense, and some of them don't. Now let me explain how intense the sun is. Let's go over to Fusion. So here's that same light probe, and if I turn down the exposure here, and then we go down and start mousing over it, you can see down here at the bottom. Look down here. We have spots that was over 2,000 times brighter than white. So what that means is when you're sampling something with that, if a sample goes out, one of them hits it and the rest don't, well, that one that hit it returns a value 2,000 times brighter than white. And that's what's causing all the speckles. Now you could wait a while and eventually that would clean it up. When we turn on important sampling, it does a great job at doing it within the diffuse channels because it knows how to direct the diffuse rays. But it's a unidirectional renderer, so it doesn't. So what essentially happens is a ray comes from the camera, hits the ground here, bounces off, goes through this, and we know for diffuse it puts more rays into where the sun is. But for these refractions and reflections, it hits here, sees a part of the ring, that ring bounces off, and then one of those rays hits the sun, and that's what's causing all this speckledness. Now, different renderers handle this differently. So I've been playing with Maxwell, Octane, C4D's native renderer, and what I've noticed is Octane, of all of them, is the one that does it technically correct, which is what you're actually seeing Lightwave trying to do here. Is it just keeps putting more rays in until it cleans out this noise. Now why that becomes tricky is because, again, this is so bright that it's going to take many samples to average that back down. So that's what Octane does, and Octane throws out enough samples, but even Octane has a hard time with that because you just have to put in a ton of samples. So what Maxwell does and what C4D does is they actually clamp those secondary rays. Because when I was doing all these tests, I noticed that they were fast, super fast, but the caustics weren't nearly this bright and not nearly this defined. So I thought, well, we can do that inside Lightwave. So Lightwave, if you go to processing, limit dynamic range is essentially cutting all the rays anything above 2 times brighter than white. So at first when I was looking at this, you don't want, clamping range is never ideal. But the nice thing about this is you're clamping it way above nothing. If you need to expose back down, it's, nothing here is a problem, because essentially what it's doing is it's doing this for internally calculating the caustics of it. Now, when I say caustics, I'm actually saying we're putting all that weight on the GI system. It's not actually doing, it's calculating in the same way it's calculating as GI. And so this, what I've noticed is this is very similar to what Maxwell and C4D do. You'll notice that it's a little more subdued, but you'll also notice how much faster that works. And it gets us very, very quickly the results that are usable without having to wait for the technically accurate thing that just takes a very long time to clean up. So that's essentially how you get caustics working, is you clamp it somewhere up above what you're using, and essentially it's a balance of how intense do you want the caustics versus how fast. So the higher the dynamic range, they'll be more intense, but it's going to take longer for the noise to be cleaned up because it's going to take more samples. So instead of 2,000 times, I'm saying, all right, 10 times brighter than white. When you do the sample, 100 samples of that will average that down, and that's how it will clean up. If I'm in a bigger hurry and I go down to 2, then it will clean up very fast, but the caustics won't be as sharp or intense as if it was actually higher. Now let me just show you some of the rendering settings to enable caustics via the GI system. So you have to use transparency enabled, and you have to have directional rays enabled, and important sampling. So that way the diffuses, and that way it'll also just clean up the speckles. What I do, you saw in the last video, I had indirect bounces up to 2. In this type of scenario, you don't really need that much because you're essentially just going through it. So 1 is fine here. I have very low rays per evaluation, and where I'm cleaning things up is over here in the anti-aliasing system. So I have a minimum of 64, but my maximum is 512, and you have to have really high samples to be able to clean that up. Now this is more important when you have very sharp, hot, intense lights. This is essentially what you need for the sun. If you have that bright of a sun, then these are the settings that you'll need to use. Now you'll see some beautiful stuff going on here where you're getting some beautiful caustics and some bouncing around that just looks really nice. Let me show you on a different light probe. So this is in a mountain trail and some pine trees. Now this one, because it's overcast, we actually don't need this anymore. We can do full dynamic range. You can tell it doesn't affect it because nothing is over that intensity. But the cool thing about this is because you see this bright sky versus these trees, you start getting this really nice effect of the light going through these glass balls, and you get some really nice caustics going inside here. So the other thing to know when you're doing caustics, especially through glass, is so I showed you the limit dynamic range and processing. The other thing we need to know is here under your render globals, your ray recursion limit. Now this is something that's saying how many times does a ray bounce off something, either bounce off for direct for diffuse, or go through something for refraction, or bounce off for reflection, but that's the maximum number. So I can set my GI bounces up to 20, but if my recursion down here is 5, it'll stop at 5. Now with especially glass, you need to turn that up. So you can see if you go to 0, it's essentially saying it's off, it's disabled, it's actually not ray tracing anything. If I go to 1, you can see, okay, diffused, I'm getting some nice stuff, but I'm getting 1 bounce of reflection here, but that's not enough to do anything. And as I go up, okay, that's enough so the ray bounces off the ground, off the ring, sees the sky, so that gets me the ring caustics. but essentially I have to go up quite a bit so that the light bounces around enough inside this glass to go from ground around in the glass, then bounce out to the sky. And that's what enables these really cool caustics. And that's the great thing about the light probes is because all the range is there, then you get to do things like this where you get this really pretty effect. I had this other one, I was just going through testing different ones. That's a little intense, so we'll just turn it down. But you can see just, this one, the sun is actually blocked by that little tree branch there. So there's no direct sun in it, but there's a lot of intense cloud, a lot of bounce off of this wall over here. And you can see when you start rendering that, just how pretty those caustics end up looking. So that's essentially a technique to get fast caustics. And again, if you have some of the light probes that have really bright lights or the sun in them, then don't forget this messing with the limit dynamic range. Otherwise, it'll just take too long. But if they don't have that, if they just have typical or not as much dynamic range, then you can just leave that off and it'll clean up fine. So I hope this is helpful, and yeah, it'll let you use light probes to get amazing caustics inside Lightwave 2015. Thanks.